Here we go. The name is Trevor Lacoste, and I'm enrolled in CompTIA Network Plus. This is the essential of chapter one to chapter six. I'm trying to make it quick so I can talk about everything in amount of time that I have. So the first thing first is I'll talk about the network topologies. There are physical and there are logical part of the topologies. The most common one is the star, which is part of the physical topologies. It connects all the devices on the network. And the second part is the mesh. And as for the mesh topologies, it provides high redundancies with multiple paths between devices, but it's expensive. And the third one is the ring and the bus topologies are mostly legacy systems you see all the network. So they moved on. Most of people they use star and mesh nowadays. So as for the network, we have LAN, WAN, MAN, and PAN. As for LAN is the local area network, usually in a single building. And as for the WAN, it's wide area network, which is for cities, countries. So it covers a wide amount of space. As for the MAN, it's for the metropolitan area network. So it's citywide. Um, those small cities that have a lot of businesses, a lot of industries. That's what metropolitan means, which is man. And as for the PAN, it's a personal area network, um, which is very small. It's a Bluetooth range, Wi-Fi range, very small for personal uses. And the OC models also could be called as OSS models. There are 7 layers. So the 7 layers, I'll go from the top to the bottom. The seventh layers is the application layers, is where the protocols like HTTPs, FTPs, and SMTP operates. This is what users interact with. Layer 6, the presentation layer right here, is it handles encryptions and data formatting. Layer 5 right here, the session establishes and maintains connections between applications. The transport layers is where the TCPs and the UDP live. This is layer handles end-to-end communications and uses port numbers. The network layer, this is where the IUPs and routings operates. The data link layers, which is the second one, this is where the MAC addresses and switches stays. As for the physical layers, um, so this is the actual cables, signals, and bits. That's what they stays. But remember, um, that's um, you have to know every single one of these layers. So this is the IP addresses and the subnettings. Um, so IP addresses is critical for the network plus, and as for the IT personnel, IP force addresses are divided into classes. There is a class A right here. I'm not gonna say the names, but this is the large network. Class B, this is the medium, uses the 128 to 191. Class C is very small. Class D, this is multitask and is usually used for experimental. Equally important are the private IP range, which is RFCs. The one 1918. There are multiple of them. These addresses are not routable on the public internet. They are used internally, organizations, and in homes. The submasks, where are they? Right here. The submask divides an IP addresses into network and host portion. The CIDR notations makes this easier. Example, /24 means the first 24 bits are the network portion, which equals a subnet mask, the one that goes with 255, 255, 255.0. Subnetting is a key skill for network administrations. Moving on, these are the protocols and the port numbers that result with them. Um, I don't want to go through them, but they right here. So which is HTTP ports. It goes 80s HTTP port S. This is for the security version of the first one. It uses 443s. Um, the FTP uses port 20 and 21, while the SFTP uses port 22, the same as SH. Where are you? Yeah, right here. The same as SSH. DNS operates on the port 53, translating the domain names to IPs. Those two are very essential. DHCP uses port 67 and 68 for automatically assigning IP addresses. For small SMP, SMTPs sends email on the port 25. Where are you? Oh, right here. Um, So yeah, for the POP3 or POP3, it receives on the port 111, IMAP port 143, RDP port 3389. This is where it talked about they use the same one as the first one, and the telnets which uses 23. Moving on. And these are the networks and devices and the hardware of them. So understanding network devices and which OC layer model they operate on is very crucial. The hubs are the layer number one devices that simply broadcast anything to all parts. Um, they all have duplex and create collusion domain. They are essential absolute. So switches are on the layer two, where the MAC addresses reside. Um, they are full duplex and create separate collusion domain for each port, making them much more efficient than the hubs. The routers operates on the layer three, and they route packets between different networks using IP addresses that connect different broadcast domain and make intelligence routing decisions. Firewalls, very essential for security. They filter networks traffic based on security rules and can operate on the multiple layers. Access point provide wireless connectivities, load balancers, distribute traffic across multiple servers and redundancies, and perform IDS and IPS systems, detect and prevent intrusion. Each devices serve a specific purpose in the network infrastructures. So yeah, exactly. This is everything that I was talking about right here. It goes into the details on my scripts. Now I'll talk about the cable types and the standard. So this has something to do with the Ethernet and the Ethernet tools, which is like the newer version of the old Ethernet cabling. There is a Car5E which supports 1 GB. It can cover 100 meters, and this is the most common one. We have the Cat6, which supports 1 to 10 GB and 55 meters at 10 GB. Yeah, at 10 GB. So this is the Cat6A is support 10 GB, and it can cover 100 meters. This is like the better version of this. So we have the fiber optics cables come into two types. There's a single mode fiber, uses the laser lights and can go very long distance, perfect for the WAN connections. And there's a multi-mode fiber, uses LED and is good for shorter distances within buildings. We have a coaxial cables used for cable internets and the TV services. RG6 is the standard. You should know this, the T560 8A and two 568Bs. This right here. This is the wiring standard straight through versus the crossovers. Moving on. Um, so now I'll talk about the DHCPs and network services, and DNS, domain name server right there. So these ones, the DHCPs and the DNS are two essential network services you will encounter everywhere you go. DHCPs automatically assign the IP addresses to clients using the DORA processes. The DORA stand for the discover, offer, request, um, and acknowledge. So the client discover available DHCPs servers, receives an IP order, offer, request that IP, and get acknowledged. DHCPs servers manage a scope or pool of available IP addresses and assign them with the least time. The DNS is the internet's phone books. So it serves the name instead of serving the IP addresses. The name, like you serve google.com, it just serve instead of serving the 142.250.185.46, the DNS server, it just serve the google.com, which is equal to the IP addresses. It makes it very easy. Without the DNSs, we will have to memorize the IP addresses for every website. Key DNS record types include and A records that maps host to IPv4 addresses, quadruple A is record for IPv6, MX record that points to mail servers, and CNAMEs record that create aliases. Both DHCP and DNS are critical services. If either one fails, your network users, they will have very, very much problems. Oh yeah, these are the key takeaway for everything that I just talked about from the slide number one to this ones. So we have to know the OC models, all the 7 layers, memorize common ports for like HTTP, HTTPS for the security version of the first one, uh, DNA, DNS, and SHS. I can say all these things, but yeah, memorize this is the common one used. Understand the subnetting, CIDR notations, and subnetting masks. Device functions, the hubs and the switches versus the routers. All these are very essential. They are used on day-to-day of an IT personnel. Cable categories. These are the cables and the specific reasons why they are used. Um, and we have the DHCP and DNS critical network services. Yeah, that's it. Thank you for your time. Oh my God. I don't wanna oh, I know.